Okay, here we are trying to catch a big fish. Okay, not a great fish. What we know is that the maximum tension in the fishing line is 35 newtons, and this is the kind of thing that you would know. They'll call fishing line 10-pound test. That means, if the force is greater than 10 pounds, you're going to break it. So we have that 35 newtons for the maximum tension, and good size fish, 4 kilograms, it's about 9 pounds. We want to know how quickly we can accelerate that fish upwards, so like as we jerk it out of the water. So system schema, person is holding on to the rope, is touching the fish, and the earth is involved. We'll neglect the water just for simplicity, or we could say that we've already pulled it out of the water. So there's a tension force the person exerts on the rope, which exerts a tension force on the fish. The fish is not touching the ground, but there's a weight interaction between the two. There are also some interactions between the person and the earth and other things, but we only care about the fish. So we have all our fish interactions. So our free body diagram for the fish has the weight down and tension up, but that tension is going to have to be greater than the weight if we want it to accelerate upward. Right? So the net force has to be upward. I'll call up positive and write an F-net equation. So tension up, the mg down, and that does not equal 0 because the forces on the fish are not balanced. So it equals the mass times the acceleration. We're looking for the maximum acceleration here. So the tension is 35 newtons at its maximum. That'll give us our maximum value of acceleration. The fish is 4 kilograms. 10 newtons per kilogram equals 4 kilograms times the acceleration. So we solve it on this side. We get negative 5 newtons divided by 4 kilograms. Newtons per kilogram is the same as meters per second squared, so our units are okay. Equals negative 1.25 meters per second squared. What does that mean? That seems very strange with the negative. Well, since we called positive up, that means our acceleration is actually down. So we really can't accelerate this fish upward. We couldn't even actually hold it without the line snapping, because it can't sustain 40 newtons, which is what the fish weighs. So we can sort of assist the fish upward if the fish is going upward to begin with, and we can slow down so that it's not in free fall. It would only accelerate downward at 1.25 meters per second squared instead of 10 meters per second squared. But we can't actually accelerate it up. We could only slow its downward acceleration, unless we had some stronger line that could exert a bigger force, and then we could do that.